Well, we're about to attack it. Just going very slowly at it. Just want to see what the profile looks like when it's gone around. That's a very long end mill that will probably chatter like hell, and I will have to probably stop halfway through to cut away these corners, because these things don't like deep full width cuts. They prefer an open side so they can eject the cuttings easily. It's still got 3mm to go before it hits any material. I could speed it up, I suppose, by increasing the speed a bit. Depth of cut maximum 0.5 mm, as recommended by the insert manufacturer. Once I get to start cutting metal, I'll put this spray on, which you can't see much there, but there you go. That's just enough to stop it sticking to the cutter. So we'll have a go later. Yeah, like I expected, it's chattering a bit, but it's cutting quite well too. And as usual, I'm having problems with the spray, but it's fine. Everything's working okay. When it puts a cut on, when it gets deep, you'll hear it start to chatter. It's quite a long. There it goes. Well, it's cutting alright now. I'm quite happy with it, I suppose. That is the finished cut for that particular depth. That is fast. And now it goes to another level. That's 1mm. The first millimetre is about another 100 to go. Anyway, enough. I think I'll be about deaf when this is finished, but it's digging out the metal quite nicely, this cutter, as you can see, and here. It's got a good way to go yet. We're on 39mm, so looking at the program or the machine, this here indicates we're about halfway through the program. And if I give you an isometric view, there you can see how far we've gone. We're down to here, we're going to go down to there. Sorry, that's how far we've gone so far. We've got to go all the way down to there. We've got 3 more millimeters to go, thank goodness. I don't think my ears can stand it anymore. Go up here, there you see the last 3mm, so we're nearly there. Well, this is it, a final cut. It's down to 83, nearly 84mm deep. Which is a long way. Well, there it is, finished. That's the first stage done. Next process will be to bore some through holes so that when I clean the inside of this out, there's somewhere for the cuttings to go, because this machine doesn't have the pump capacity like you see the big CNC machines that blast everything with tons of coolant. Apart from anything else, it's a bit of a nuisance, coolant stuff. It gets everywhere. Sort of aluminium cuttings, it's all over me. Anyway, that's enough for now. Well, what we've got here is the gearbox. What I've done is bored 2 half-inch holes, or drilled 2 half-inch holes using my drawings. I made a couple of mandrels. Well, that's just a piece of half-inch rod, and it's a good close fit in there. This is a specially made mandrel to fit this gear, and as you can see, they turn quite nicely. There's no problem with that. I think that's perfect, so I don't think that's going to cause any problems. And I know that I've measured the centers correctly, otherwise they wouldn't mesh that well. They go together really well, so I'm dead pleased with that. It means that I can now go ahead and bore out take all the interior of this out, knowing that these centers are okay, and then eventually do the counterbores to take the bearings, etc. But that's the next phase. Well, here we are at phase 1 of gouging out this stuff. You'll notice that it's slightly smaller. I'm trying to increase the wall thickness of this. Effectively, this stage will take it down to this level here, where you can see. And at that point, I'll start boring out the counterbores here for the bearing, and this section here, and final boring of that through hole there, which needs opening out just a touch. But it could be a 2 or 3 stage joint this. Here we are on phase 3. I don't know if you can see in there. I'll try and blow some of the cuttings out. I'm using a boring program, pretty boring. And as you can see, it's taking that material out down there where the end of the brass nozzle is. That's got about 20 millimeters to go. And then I'll move it, center it over the other hole, and do the same on that side. Okay, well, there you can see that's that bore all the way down to the bottom of what would be the bottom of the casting on this side, just here where my finger is. That's it up there. Looks slightly different to the model, and that's because of slight differences between the drawn stages. It's not going to make any difference at all. The main thing is that the bores are concentric to, excuse my fingers, the bores are concentric to the holes that go right through, and that's all that matters to me as far as I'm concerned. This part here, when I do that side, will form what you see here where the big blob of weld is. It'll form that. It won't be exactly the same, but I hope there will be enough room, clearance room for that hole, but it's a case of is there enough clearance room at the top of this the top of this part here for the, I believe it'll be the selector arm. I'll probably open that up manually using manual mill techniques just to open it up a little bit more. But as you can see, it's quite a bit smaller on this. It's coming on. I'll probably get this finished this evening, down to the step bore, bored out to the full size hole that goes right through for the main shaft. And what I will do is I will mill the seating for the bearing to within about 10 thou, 15 thou. Then I'll put the boring head in and actually bore that out to the correct size with a long boring bar in. I don't want to have to take massive amounts out, so that's the best way with that. And then I will give it a try with gears in place, or try to anyway. I'm not going to put the bearings in. I'm pretty sure they're okay anyway, as long as everything lines up, it'll be fine. It's just a case of whether we can get everything into the gearbox. I think we should be able to. Well, I'm cutting a little bit of air here because I'm not too happy with the amount of room I've got on that side of the gearbox. A little bit close, and there's plenty of metal there, so I'm going to open that out all the way down to the full depth, so that's going to take some time, probably most of the evening. And there you go, you can see I have finished boring out both of the pockets below this shelf here, and I've also bored what will be the through hole, this hole in the top of in the back of the gearbox for the main shaft to size. Not the size, but that's the through hole. It's not an important one. What I had wanted to do tonight was to put the pocket for the bearing in here, but I just haven't had time, run out of time, and I've also got to finish boring this out to size. It's awkward jobs these because you're working at depth, so I think what I'll do is make a plug gauge for the bearing so that I know that it will be about 2 thou undersized, this hole, so you can shrink the bearing in, and I'll machine that to size. But I'll be working at the maximum range of my boring tools, which could make a lot of chatter, but I don't think it will. It should be okay. I'll do something about it and we'll get them sorted. Okay, what we're up to at the moment is making a mandrel, a false mandrel for that gearbox, so that I can put the cluster into the box with the cover and translate or transfer the centre for the, let me turn that off, the centre for the selector rod, get the centre for that with the lid in place or with the cover in place from the hole in the cover, and then I'll be able to drill that and hopefully finish all of the machining of the inside of the box before I remove it from the vise on the mill to do the front face. The idea of that is this is the gear that goes through the side of the gearbox. That has to slide, well, that has to go on the shaft. It's nearly there, and this will go down eventually over this and sit in the large hole in the gearbox that I've already cut. That's a close fit in there. The other gears fit onto a shaft that's fitted into the cover, so I'll be able to put the whole lot together as a cluster, know that the shafts and the gears are in the right place, and then, as I say, pick up the 0 point for that hole and just drill it and get that sorted, because that's quite important. At least then I know that when I put the cover on with all the gear, the stuff in it, everything's in alignment. It's not going crazy and causing problems. Well, that's the cover on with this shaft in the hole and the mandrel fitted into the top bearing and into the hole at the bottom, so everything's in alignment there, and you can see it's looking pretty square along the bottom, So what I will do is then I will pick up the center of this hole, remove all of this, and then go in there and drill it. So, and then I will probably spot these once I've got that done, because the next phase I'll probably drill and tap these holes, attach a plate to the bottom so I can machine the top or the front face of it, because that's got to be machined very similar to this. So we shall have a look see. Okay, what I'm doing now is I'm finding the centers of these holes. Now this hole here, which it takes the gear change, the selector, it's a selector shaft. There's a bit of corrosion in that hole, and it's not very good in terms of true roundness, but if I run around the 4/4 of this corner, you'll see it's saying about, what, 3 divisions. Then in that corner, about one away from that 0. There it's just about the same, 1 or 2, and there it's about the same. That's about as close as I'm going to get that. It looks horrendous when you see that, but there's not much I can do about it. And those horrendous things that you see, each one of those divisions, although it looks a massive amount, it's 0.01 of a millimeter, so that's 0.02. 0.03 is about 1 thou, I believe. So it's not going to affect things that much as long as that's accurate enough. That should be fine. So what I do now is I'll take a note of my X and Y coordinate on here and transfer them into this chart up here, and that'll give me the position of that hole for when I go to spot drill it when I take that cover off. So that's the next phase. What I will do, I'll change this out, and then I'm going to put this chuck here in. It's got a piece of 8mm steel in, and I'll center above each hole, just make sure it goes in there without disturbing anything, and I'll give the coordinates for that, and then I'll drill those holes, because I'll need a couple of them drilled and tapped to so that I can clamp it to a plate to finish off the back surface of it. Anyway, I'll get on with things. Okay, well that's the 6 hole positions marked in on the chart. As you can see along the top of here, there's various, these are called wizards, and basically that's for flat facing something, that's for making either a square profile or a round profile. In other words, something sticking up above the surface of the metal. That's for making a pocket, i.e. Any kind of hole in the work, as the inside of that gearbox is. Then you've got drill and tap, which this is a drill and tap, but that also works for the pocket and the profile. If you want to do a round profile, you can put the coordinates at the center of that round. Similarly, the round pocket, you put the centers in here, and then you can take it off there. Thread milling, different process altogether. That's rotating the spindle with a cutter to generate a thread rather than rotating a fixed amount. It rotates like a rotary cutter that descends in a spiral motion to generate the thread. I think I've shown you that one before. Engrave, that's pretty self-explanatory. Various bits and pieces you can put in there. DXF, that's a drawing file. I believe you can bring drawing files in here, 2D drawings, and pick off the coordinates from them. I know I tried it. I might be talking rubbish there, but anyway, it's something I've not tried and probably won't. But that's it. Anyway, I'll get on. We'll get the drill sorted out, the drilling program and so on, and get after it. Okay, what we're up to at the moment is making a mandrel, false mandrel for that gearbox, so that I can put the cluster into the box with the cover and translate or transfer the centre for the, let me turn that off, the centre for the selector rod, get the centre for that with the lid in place or with the cover in place from the hole in the cover, and then I'll be able to drill that and hopefully finish all of the machining of the inside of the box before I remove it from the vise on the mill to do the front face. The idea of that is this is the gear that goes through the side of the gearbox. That has to slide, well, that has to go on the shaft. It's nearly there, and this will go down eventually over this and sit in the large hole in the gearbox that I've already cut. That's a close fit in there. The other gears fit onto a shaft that's fitted into the cover, so I'll be able to put the whole lot together as a cluster, know that the shafts and the gears are in the right place, and then, as I say, pick up the 0 point for that hole and just drill it and get that sorted, because that's quite important. At least then I know that when I put the cover on with all the gear, the stuff in it, everything's in alignment. It's not going crazy and causing problems. Well, that's the cover on with this shaft in a hole and the mandrel fitted into the top bearing and into the hole at the bottom, so everything's in alignment there, and you can see it's looking pretty square along the bottom. So what I will do is then I will pick up the center of this hole, remove all of this, and then go in there and drill it. So, and then I will probably spot these once I've got that done, because the next phase I'll probably drill and tap these holes, attach a plate to the bottom so I can machine the top or the front face of it, because that's got to be machined very similar to this. So we shall have a look see. Okay, what I'm doing now is I'm finding the centers of these holes. Now this hole here, which it takes the gear change, the selector, it's a selector shaft. There's a bit of corrosion in that hole and it's not very good in terms of true roundness, but if I run around the 4 quarters of this corner, you'll see it's saying about, what, 3 divisions. Then in that corner, about one away from that 0. There it's just about the same, 1 or 2, and there it's about the same. That's about as close as I'm going to get that. It looks horrendous when you see that, but there's not much I can do about it. And those horrendous things that you see, each one of those divisions, although it looks a massive amount, it's 0.01 of a millimetre, so that's 0.02. 0.03 is about 1 thou, I believe. So it's not going to affect things that much as long as that's accurate enough. That should be fine. So what I do now is I'll take a note of my X and Y coordinate on here and transfer them into this chart up here, and that'll give me the position of that hole for when I go to spot drill it when I take that cover off. So that's the next phase. What I will do, I'll change this out, and then I'm going to put a chuck, this chuck here in. It's got a piece of 8mm steel in, and I'll centre above each hole, just make sure it goes in there without disturbing anything, and I'll give the coordinates for that, and then I'll drill those holes, because I'll need a couple of them drilled and tapped to so as I can clamp it to a plate to finish off the back surface of it. Anyway, I'll get on with things. Okay, well that's the 6 hole positions marked in on the chart. As you can see along the top of here, there's various, these are called wizards, and basically that's for flat facing something, that's for making either a square profile or a round profile. In other words, something sticking up above the surface of the metal. That's for making a pocket, i.e. Any kind of hole in the work, as the inside of that gearbox is. Then you've got drill and tap, which this is a drill and tap, but that also works for the pocket and the profile. If you want to do a round profile, you can put the coordinates at the centre of that round. Similarly, the round pocket, you put the centres in here, and then you can take it off there. Thread milling, different process altogether. That's rotating the spindle with a cutter to generate a thread rather than rotating a fixed amount. It rotates like a rotary cutter that descends in a spiral motion to generate the thread. I think I've shown you that one before. Engrave, that's pretty self-explanatory. Various bits and pieces you can put in there. DXF, that's a drawing file. I believe you can bring drawing files in here, 2D drawings, and pick off the coordinates from them. I know I tried it. I might be talking rubbish there, but anyway, it's something I've not tried and probably won't. But that's it. Anyway, I'll get on. We'll get the drill sorted out, the drilling program and so on, and get after it. There we've got the dummy shaft I made with the, could call that a dummy bearing to fit in the hole I've cut bored. There's the selector on the sliding gear. The other gear can't fit in here because of this space here and the fact that it sticks out through the front of the gearbox, and the hole that I've machined doesn't go, it's not big enough to go right through fully. So I'm going to try that in here and try and get all the holes lined up. Bring it back when it happens, if it happens. Well, success, it's in. It looks pretty good, and the selector shaft slides up and down freely in there, and I'm pretty certain the gears will go around. If I could get my finger down that hole and feel it, I would. But that's lovely, it all fits in. So I'll now drill these holes and then not worry about doing the bearing recess. Maybe tomorrow, I don't know. Anyway, good progress. Well, on the screen there, these represent the tool paths. Five holes being drilled. I've already drilled the one that's in the centre. I drilled that using the settings in a manual mode, but these will be automatic, kind of automatic. I'm just going to start the machine off and see how it's going to perform, and I'll bring it back while it's running to show you what it actually. Okay, well, we'll start the machine and see what happens. And there we have I'll bring it down slowly, because the last thing you want to happen is for this to crash into the work and snap a drill point off. Now, according to that, it's got to go a little ways to top of the work there. So now if I slowly bring the feed up, that should make 2 passes, 2 millimeters, and then back out again. It didn't, but never mind. And there we go. I haven't got a 1/4 inch Whitworth, 5/16 Whitworth tap, so I'm going to do those 5/16 UNC. If you find a Whitworth tap, just run that down. The difference is a slightly larger thread angle on the Whitworth, I believe. Thread, or a coarse thread, which is what you need for alloy. Right, that's it, spot drilled. So now if I change over, put the long drill in, it should drill some nice 25 millimeter deep holes, which is plenty deep enough for the studs. Okay, well, we're finally got to go, and the eagle eye amongst you will spot that the drill actually dragged just across the surface of the work there, which indicates that it's actually just not quite on zero. In other words, my length measurement wasn't quite right. I don't use electronic means of checking it. Anyway, never mind. 25.4 after this one, and here we go, and across to the next one. And it's as quick as that. I could, if I was really being smart, tap these using a tapping head, which I've got, but I think I'll do it manually. I just don't want to break anything off in there, and you need machine taps for it. I haven't got blind hole machine tap to suit that size, but you've got to be doing a lot to warrant the setup. It takes quite a bit, so I'll just use the chuck that's there as some kind of guide and tap the holes, and that'll be tonight's exercise finished, because it's taken a long time to get this far, but I'm really pleased with the way things look. Okay, there you go. As you can see, all 6 holes drilled. You can see the mark where the drill dragged across. Unfortunately, that was due to me, bad measurement. So there you go, and it is a Whitworth thread in there. I found one decent UNC tap and one broken Whitworth tap that had been ground. I'd ground the end flat, and I used that, and they'll take a Whitworth thread nicely now. And I've got a Whitworth die, so I can make some bolts, so that when I go on to the next phase, I can bolt it to a piece of plate and machine the top face or the back face of the gearbox. Anyway, enough for one night. I'm tired, I'm going to bed. Night night, or good night, said Zebedee. Yeah, you can't really see much more. Basically, I've bored using this boring head, which is a lovely piece of kit. 0.01 one marker here is 0.01 of a millimeter diameter change. It's phenomenal. It also acts as a facing head. If you rotate the spindle, you put a bar in here, hold the bar. It terrified the thought of me at first, but you hold the bar and it rotates, and every time this rotates, I don't know if it's set up to do it, but it's not at the moment. But if I think if I click that round, it maybe will. No, it's not. I think there's some pegs that have to be knocked down. Can't remember. It's that long since I used it. In this gap here, you put a little wedge, and that pushes a button down, and that engages the auto feed. And the auto feed slides this across as it rotates. Slides this part across, and you can face the bottom of a bore. But I didn't need to do it on this one, and unfortunately I overbored this hole, but like they just had to make a new bushing with that. That's pretty straightforward. I'll leave that up to Andreas. But basically that's this finished, so I should be able to turn it over and start work on the other side later. Not today because it's zoomy tonight, and I will speak to one or two of you later. Okay, here we are back in the workshop again, ready to remove some metal from here to expose most of that gearbox. I'll have to remove the boring head from there and replace it with this facing head. There's one or two cuttings that get everywhere. They're even in the bed. We'll be using conversational programming. This is conversational programming here for you. And these are the various bits and pieces that you can get. We're going for facing because that's all I'm doing. I'm going to remove that metal, just cut it away. and with 0.5mm cuts, which is quite deep for that thing, but that's what I'll use. But I'll have to put the coordinates in to give the right sort of finish. You can have spiral or rectangular paths. Rectangular I prefer. We'll go for that, and I'll have to be very careful as I get down to where it's going to cut that apart, because there'll not be much metal and it could create a lot of problems. So I'll probably end up stopping just before it breaks through and actually snapping that off, or snapping off the excess, or milling it out with a small cutter and following a path that's not as dangerous as it is when it gets down close. Anyway, I'll bring you back once I get started. Okay, well, we're just set up to do some facing. As you can see, it's run it across a little ways. It's not particularly flat, this, but it's not bad. There we go. I'll speed things up a little in a minute or two. In fact, I can do that now. Bring the RPM up. And by the time this thing's finished, there'll be cuttings everywhere. But as you can see, it really does well, this cutter. I better get some more coolant on there, otherwise we're okay. Right, well, we're nearly there. I stopped when it got to a very thin section here, because if these break loose, they get jammed under the cutter, you do all sorts of damage. So I got the tin snips out and just snipped through that, cut that off, and these two I managed to pull off because they're a bit lighter section. So there's only one more pass to do, I think, possibly two, and it should I'll just go easy on it, because there's all these little bits of metal can easily get jammed under the cutter. They make an awful noise when they do as well. So do I. Right. With a bit of luck, it will expose the full profile setting up. Maybe not. I don't know. We'll see. I think this is the last pass, so I'm just going to take it easy on the speed, on the feed. And there you hear it. Now you know why I don't like leaving great chunks like that. If that had been a big thick section, it would have really made done a lot of damage. There you go. And it's beginning to expose it. That's great. That's really good. Beginning to look a bit more like the original now, without the blobs of weld, by the way. That's it. Good. Well, not quite. Okay, that's it. Good enough for me. In case you wondered why they put enclosures around machines like this, and drown everything in coolant. Yeah, there's a lot of cuttings here, but there's a lot of cuttings on me as well. And on the floor, and all over the control panel. So I'll probably spend a good part of this evening sweeping that lot up because it just treads everywhere. Well, just occasionally I have to go back to the drawing board, and this is one of those occasions. I just cannot get to work to, if you look here, the yellow line is where I've moved the tool around. I just can't get it to follow this contour. And if you look at my XY, that's the origin. I don't know how the hell it's over there. I'll have to go back and take a good look at things. Maybe something to do with 3D drawing, but I'll find out. Ideally, that should be in one of the holes, either the small one or the large one. And the small one was the one that I referenced everything else to originally, but I don't know where it's gone on this drawing. So I'll go back to the drawing board and sort it out, and then maybe tomorrow I'll get the outside. I'll get this kind of nicely done along here. I could do it manually, but I've got a machine, I might as well use it. And okay, I know there's a couple of old cloths in here and some bits of junk in here, but that's the pile of cuttings that's been generated so far. I managed to sweep a few bits up off the floor, not much. It's awful stuff, especially if it's raining outside. You go out, you get your shoes wet, come in, everything sticks to them, and then you go in the house and the wife goes mental because it's all over the place. Anyway, I'm going to go back to the drawing board and sort this out, and we'll carry on tomorrow. Okay, works best when you switch on the video. These are long series end mills. I was going to use something like this for getting down to here, but unfortunately they aren't long enough. This one is, it's a big diameter, etc., and I think it'll fit, so I will see what it looks like in the... Well, here we are, back in the torture chamber, and as you can see, we're making it look a bit more like this. I'll bring you back when it's a bit closer to being correct. Well, we're getting on quite well there, you can see. The screeching is chatter from the cutter. Basically, I'm holding on to that cutter by very little. It's working at way beyond its maximum depth. It should only be really gripped. Should only be milling about 40 millimeters deep at the most. This is going to be milling 70 millimeters, which is quite a lot. Well, there we have it. It's not perfect by any stretch of the imagination. It's a little bit stopped a little bit short here. I might even run the cutter down there a little bit, but in all probability, well, it's easier done with a Dremel, to be quite honest. The sharper edge there, you just dress them out with a Dremel, and you can't, you know, these sort of slight marks. After all, it is meant to be a casting. If it were perfect, it would look stupid. I mean, you can't say that looks like it's been machined. That does. So, you know, you're going to have imperfections in it somewhere. I notice as well, there's a big difference in that hole to that hole. That one's bigger than that. But inside it's bigger. It's just not through. I didn't have enough tool length, so I'd forgotten about that. I'll open that up when I finish this. I've next got to make a program for this end and this end. Shouldn't take too much, but you never know. Anyway, at least that eventually that worked, and that's a large part of the cosmetic look of the article finish. So here we are, we're on the second run of profiling the outside. It's looking not too bad, going quite well. tool's doing a good job. Well, the eagle-eyed amongst you will have spotted I've changed the clamp, and you'll see a reason why. When it comes off from the work, it's going too far back, and it looks like it could foul the clamp. I'll keep an eye on it as it gets closer to it. I think it should be okay, but obviously I'll slow things down and check it out as we get closer, because the last thing I want to do is machine the clamp. Well, everything seems to have gone okay. This is the last cut, I think, and we'll soon find out. Yep. And that went really well. That's good. Each of these sides, the programming takes me a couple of hours to get right so it looks good, and this does look good. It's come out really well, as you can see here, and on the top it's really nice. It's getting to look more like this should, well, like this should, or this should have been. Well, that's it for the last bit of external profiling around the edges. It's a bit noisy. I think the cutter's getting a little bit tired, but never mind, it'll last. Well, here we are. We have finally, I should have put some more light on the subject. We've got the profiling around the three sides that are profiled like this on the casting. So that's that stage. The next stage is to profile the top like this without the blobs, and also to mill down to this depth from this face. So on here I'll mill 1/8 of an inch of material off. It's basically just to align the gearbox when it's in the frame. Then I will turn it all over, do the other side, attack that, and then I'll turn it that way and drill and tap those holes. Then I'll make a bush, and then I'll push the bush in, and I might even make a dummy bearing just to assemble the gearbox, just to satisfy myself that the machining's okay. But we shall see. Well, here we are, well, not the final stage, but could be the penultimate stage. We're taking the material off the top so it represents this. And as you can see, at the moment I'm cutting air because it's set a little bit high. That's machined to its correct depth, and the starting point is 0. So it's very close to cutting. I'm not too concerned if it's a little bit thicker than it should be. It's not going to make any difference. So we'll see how it goes, and I'll bring you back when it starts cutting and looking right or wrong, whatever the case may be. Well, it's cutting metal now. We'll see what happens. It's done exactly what I wanted it to do so far, so looking promising. Well, you can see here that it is following this contour. So far, so good. What it's doing there obviously is clearing the metal at this point. So looking good. Well, signs of real progress here. You can see now it's starting to leave this profile here. You can see the paths have changed. I was beginning to think it wasn't going to do anything, but it is. And it looks to be profiling slightly on the radii, so I'm quite happy. It should turn out okay. If it doesn't, I'll jump off the time bridge. Well, it's chugging away quite nicely there. You can see just the way the tool paths go. You can see it's worked its way. It's done all around this profile first, and now it's digging away at this stuff. So hopefully, fingers crossed, no more messing around, and we'll have all the cosmetic stuff done. Okay, well, as you can see, there we have it. These marks here are very, very light. They're where the tool has actually not quite cleared the work, and the difference is just that basically a tiny bit of the measurement of the length of them. But these will all dress out. Using a round nose cutter doesn't do a lot of good for finish, obviously, because each of these is basically the tip of the tool digs a little furrow, and then of course I think I limited it to 1 millimeter of movement across. Otherwise, it would have taken about 3 weeks to do. I have done it before with much finer cuts, but it takes so long, and it doesn't take long, especially with aluminium, to actually dress out these marks. Another thing about dressing out the marks is, of course, it makes it look like a casting, and that's what this is meant to be. So I'm really quite pleased with it. There's a nice fillet on there. All I've got to do now is let me just zoom back in, out rather, the strip a piece of metal taken off here, but I'll have to reset the machine to do that. And I think this here is, there's so little material there, I'll just take that out with a file or a deburring tool, rather than try and machine it out. The finish is okay on the other side. It's deep enough for the bush. It would be pedantic to set it all up just to machine that. I've got that to do, and then I've got to put it with this face parallel to the machine bed, and drill and tap the two large. I think they're 1/2 inch width, but they could be 7/16. I'll find out anyway. I've got some really ancient taps in there somebody gave me. I might use them. But to do this profiling, I was really surprised, because there's thousands of lines of code. I thought it would take a long time, but actually it didn't. I think all of this was taken off in less than an hour. In fact, a lot less than an hour. So I'm well pleased. Well, that's the mounting bridge, if you like, done. This, and the hole's tapped. These are tapped 1/2 inch UNC. I couldn't find my Whitworth tap. UNC and Whitworth are pretty close. I believe Whitworth is a slightly wider angle. I think it's 60 degrees versus 55 thread flank angles, but you can usually, it might not be a bad idea to actually put these in with a Whitworth, because then they'll stay tight, if you see what I mean. But anyway, that's for Andreas to decide. Pretty pleased with progress so far. There's very little left to do now, apart from maybe make a bearing and throw it all together and see what it looks like. Well, here we have the almost finished article. Just got that hole to open out. There's not much metal there to take out. And that's it. What a job, but an enjoyable one. And now I'll be able to get rid of all those cuttings from my garage, my workshop. It's rather packed. But once this has been filed and smoothed down, all the machine marks taken out and shot blasted, you will not know it's not a casting. I've done this sort of stuff before, and I know they look really good. But I'm well pleased with it. It's turned out good. Nearly dropped it. You know, if you compare it to the broken one, it's a pretty good. Oops, I'll take that there. It's a pretty good likeness, you know. and it's without lumps, and it's whole. If you look closely too, you'll see, if you compare the new with the old, there's a hell of a lot more meat on this one than there is on that one, and the material is probably twice as strong as the original material, so you've got a lot stronger gearbox. So that's about it. It's I'll have it finished tomorrow completely, apart from the shot blasting and sanding down, which I'm leaving to Andreas.